Okay, so now before we get to the full wave, we can look at a few questions and test our understanding on single phase half wave rectifiers. So there is a question here. So a diode whose internal resistance is 20 ohms, whose internal resistance is 20 ohms, is to supply a 1000 ohm load, a 1000 ohm load from 100 volts, from should be 110 volts, and this is the RMS source of supply. Calculate first one, peak load current. A is the peak load current, and B, DC load current, DC load current. We also have AC load current. Then we have DC diode voltage, DC diode voltage. Then we have E, that is what we call total input power to the circuit. Total input power to the circuit. Then percentage regulation. Percentage regulation from no load to the given load. From no load to the given load. Yes. So we shall start by getting the peak load current. So the solution, peak is the same as the maximum. So when you talk of the peak load current here, we are talking of the IM. So part A, peak load current will be equals to, and that is our IM, will be Vm, now from Ohm's law, will be Vm divided by Rf plus R or RL. Actually, we were given Rf, that was the internal resistance of the diode, and we were given the resistance of the load. So how do we get the Vm? Because we have the Vrms. So Vm is normally root 2 times VRMS. So our IM will be root 2 times the VRMS, which is 110. We divide by total resistance. Here, RF was given as 20, and our RL was given as 100. So this will give us 152.5 milliamperes. 0.5 milliamperes. That is the solution for our part A. That is the peak load current. So now we can get the DC load current. So part B, DC load current. So DC load current, that is what we call the IDC, is given by IM divided by pi. That is as per our derivation or under the analysis. So our IM is here. That is 152.5 divided by pi, which gives us 48.5. 48.5 milliamperes. Yes. Then we go to part C. That is AC load current. When we see the word AC here, we are looking for the RMS current. So part C, this is the RMS, root mean square. RMS current, which is I RMS, is given by IM over 2. IM all over 2. Just the same way we derived for the voltage, VRMS was Vm over 2. And we know that current waveform and voltage waveform, actually they are similar. So for sinusoidal waveform, so now the same here, our root mean square value of current will also be Im over 2, the way we had Vm over 2. So we have our Im, which is 152.5, 152.5 divided by 2, giving us 76.2. 26.2 milliamperes. Then that was part C. We go to our part D, DC diode voltage. DC diode voltage. So part D, DC diode voltage. That is our VDC, which will be IDC times RL. IDC times RL. RL we were given as it was 1,000. It was given as 1,000. So we shall have IDC, which is 48.5. Our RL, so it was 48.5 milliamperes. So we multiply by 10 power negative 3 so that we have it in amperes. Now times 1,000. Times 1,000. And this gives 48.5 volts. 48.5 volts. So that was part D. Part E is the input power. input power. So which we denote by Pi, which is I RMS squared times the total load here, RL plus, mean total resistance, load resistance plus RF. So our IRMS is here, and it is 76.2 milliamperes. We multiply by 10 power negative 3. Then RL plus RF, this was 20 plus 1,000, that is 1020. And we square our current, so times 1020. This gives 5.92 watts. 5.92 watts. And the last part of it is the percentage regulation. Percentage regulation. Percentage regulation, which is given by no load voltage minus full load voltage all over full load voltage times 100. So for our no load voltage, that is, it is going to be our Vm over pi minus, now the full load voltage will be IDC. So we subtract IDC times RL. Now will give us the full load voltage divided by IDC times RL times 100. So Vm, we know it is √2 times 110 we divide by pi to give us the Vm over pi minus 48.5 all over 48.5 times 100. It gives 2.06%. 2.06%. So that is the solution for that particular question. So maybe I can do the last one, which also considers other parameters that we had looked at. The last question here. So our example 2, a half-wave rectifier, a half-wave rectifier has a forward resistance, has a forward resistance (500 ohms). If the secondary voltage, if the secondary voltage is 400 volts maximum is 400 volts maximum. Calculate. So part A is supposed to calculate IM, IRMS, IDC. That is in part A. Part B, DC output voltage, part C, AC power input, AC power input and DC power output, and DC power output for a load of 3,500 watts. For a load of 3,500. So that was part C. Then we have D, TUF. So the solution, part A, you can get the VM. VM was given as 400 volts. So therefore we can get IM, which will be VM all over RF plus RL. This is 400, 500. Actually, this load is 3,500 ohms, not watts, ohms. It should be ohms. So 500 plus 35. This gives you 100 milliamperes. So that is our peak current, or the maximum current. Then we have to get IRMS. IRMS, which was IM over 2. So we have our IM, that is 100 all over 2. It gives you 50 milliamperes. Then we have IDC. IDC, which should be given by IM all over pi. IM over pi. Our IM is 100 divided by pi. It gives you 31.8 milliampere. So that is part A. That is part A. Now part B, we have to get the DC output voltage. DC output voltage. That is the VDC. DC output voltage. That is the voltage actually across the load. So it is our IDC times the resistance of the load, which is 31.8 milliamperes. So we multiply by 10 power negative 3 so that it is in amperes times 3500. This gives you 111. No, it is 1113. 111.3 volts. It is 111.3 volts. That is our DC output voltage. Now we can get the AC input. Part C, AC input power, that is the PAC. So this will be IM all over 2. Yeah, we know that IM is the RMS. The RMS, so times RF plus RL. So our RMS, which is IM over 2, is here, 50. So it is 50 milliamperes. So 50 times 10 power negative 3 squared times. So this will be 4,000. So what was our RF? We had 500 plus 35. It gives us 4,000. So it will give us 10 watts. Then the efficiency, so therefore rectification efficiency is given by 40.6, we saw that, all over 1 plus RF all over RL. So if we substitute, so 40.6 all over 1 plus 500 all over 3500 will give us 33.5%. 0.5%. So having known that, we can get the DC power output, because we know that efficiency is the DC power output all over the AC input power. So DC power output that is what we call P naught. It is the efficiency times AC power input. AC power input. Yeah. So efficiency is 35.5%. That is over 100 times 10, which gives us 3.55 watts. 3.55 watts. Then lastly is the TUF, transformer utilization factor. Transformer, so TUF, So to be 0.286 all over 1 plus RF all over RL. So 0.286 all over 1 plus 500 all over 3500. This will be 0.249. That's all. So we can get more questions on single phase half wave control rectifiers. So now the next one will be full wave rectification. Full wave rectification.